Very important concept. Let's see the statement. The name of the concept is areas of similar triangles. Now let's see the statement. It says the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. Now when you read the statement first time, you won't understand anything. Let's understand it in bits and pieces now. It says the ratio of the areas of two similar triangles. That means we need to have two triangles which are similar, right? So let's consider two triangles. One is triangle ABC and the other one is triangle PQR. We are saying that these two triangles are similar. That means triangle ABC similar to triangle PQR. The statement says the ratio of the areas of these two similar triangles. That means we are saying the ratio of the areas, that is area of triangle ABC upon area of triangle PQR. That is what the first part meant. So ratio of the areas of two similar triangles is equal to, so this is equal to the ratio of the squares of their corresponding sides. What do you mean by that? Before we get into that, what do you mean by corresponding sides here? You know that when two triangles are similar, the ratio of their corresponding sides are equal. So which are the corresponding sides now? AB corresponds to PQ, then we have BC corresponds to QR, and we have AC corresponds to PR. This is what we know, right? These are the corresponding sides. So it says it is a ratio of the areas of two triangles is equal to the ratio. So again we take ratio, but ratio of what? Ratio of the squares of the corresponding sides. Now let's consider one pair at a time, right? So we are talking about AB and PQ. So it will be the squares of their corresponding sides. That means it will be AB square upon PQ square. Same way if we take the next pair, it will be equal to BC square upon QR square. And if we take the third, that is AC and PR, we'll have it as AC square upon PR square, right? So that means what you understood is this theorem can be used, can be applied when two triangles are similar. And whenever two triangles are similar, we can write that the ratio of the areas of two similar triangles is equal to the ratio of the squares of the corresponding sides, right? This is what you learn. But remember, this can only be applied when two triangles are similar. That's a condition which we need to understand. So let's do that. Let's do a sum based on this for you to understand the application of this concept now. Let's take up a sum. So here we have a sum where it says that triangle ABC similar to triangle DEF and their areas be respectively 64 centimeter square and 121 centimeter square, right? If EF is equal to 15.4 centimeter, find the length of BC. That is what you're supposed to do. Let's understand this, how we are going to do that, right? Triangle ABC and triangle DEF are similar to each other given to you. So we write that triangle ABC is similar to triangle DEF. These two triangles are similar, right? And their areas be, what is given to you is area of one triangle is 64 centimeter square and area of the other triangle is 121 centimeter square. If EF is equal to 15.4, find BC. Now tell me, what do you know when two triangles are similar? Remember we are talking about area here. So if you talk about two triangles which are similar, when we talk about the areas, we just learned that the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. That means we can say that area of triangle ABC upon area of triangle DEF will be equal to, right, the ratio of the squares of their corresponding sides. Now we have three pairs of corresponding sides. Which one to select here? Remember, here we are talking about BC, finding BC. So for BC, which is the corresponding side? EF. So we should take that is BC square upon EF square. This is very important. And we know that the reason is the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. Now it's going to be very easy. We just need to substitute the values. We know that already in the sum, we have been given that area of triangle ABC is 64 centimeter square and area of triangle DEF is equal to 121 centimeter square. So we substitute that is equal to BC square upon EF square. Do we know BC? No, we keep it as it is. But do we know EF? Yes, that is 15.4. So we substitute that now. It's over, substitution done. Now let's solve it. We want BC square on one side, so we keep it there and take everything on the other side. So we'll get it is equal to 64 into 15.4 the whole square upon 121. We got that. Now we're going to solve. If you take, now we don't want BC square, we want only BC. So we're going to take square root on both the sides. To taking square root, we would get now BC is equal to square root of 64 is 8. Square root of 15.4, the whole square is going to be, yes, it is 15.4. And square root of 121 is nothing but 11. And now we can do the cancellation. So it is 11 ones and 11 1.4. So that means now we get 8 into 1.4 is nothing but the value of BC. So now we get the value of BC as 11.2 centimeter. That's the sum. Wasn't that easy? Now we have understood the application of that particular concept, right?